Hello, I'm glad you're there. Kindly subscribe to this channel if you've not done so. You really need to share and like this video. The topic is development of the maxilla. Development of the maxilla. Kindly go and watch the video on development of the mandible. The video on development of the jaws emphasized the development of the mandible. This video is talking about the development of the maxilla. So you need to know that the maxilla, like the mandible, develops from a center of ossification in the mesenchyme of the maxillary process of the first branchial arch. You don't have any arch cartilage or primary cartilage in the maxillary process, but the center of ossification is closely associated with the cartilage of the nasal capsule. Just like you have in the mandible, the center of ossification appears in quite related to the division of a nerve. That the center of ossification appears where the anterior superior dental nerve is given off from the inferior orbital nerve. You remember the inferior orbital nerve? Yes, a branch of the trigeminal nerve. That's the fifth cranial nerve. So from the center of ossification, bone formation spreads posteriorly below the orbit toward the developing zygoma. The bone ossification also spreads anteriorly toward the future incisor region. Ossification also spreads superiorly to form the frontal process of the maxilla. So you have bone deposition going on, and a bony trough, like a canal of bone, is formed for the infraorbital nerve. The infraorbital nerve now has a canal, a bony canal. So from this bony canal, you have a downward extension of bone, and this downward extension of bone forms the lateral alveolar plates for the maxillary tooth gems. So you have ossification spreading into the palatine processes to form the hard palate. You also have the medial alveolar plates developing from the junction of the palatal processes, and the main body of the maxilla is also formed. You have the medial alveolar plates together with the lateral alveolar plates forming a trough of bone around the maxillary tooth gems that will eventually form the upper teeth. And this trough of bone eventually becomes encased in bony crypts. So you have the developing teeth enclosed in bony crypts. So you have a trough of bone formed around the maxillary tooth gems, and these maxillary tooth gems are going to form the upper teeth. The maxillary tooth gems will eventually become enclosed in bony crypts, just like you have in the development of the mandible. So you are appreciating the similarities in development of maxilla and mandible. You have a secondary cartilage that contributes to the development of the maxilla. You have a zygomatic or malar cartilage, which appears in the developing zygomatic process. And for a short time, this adds considerably to the development of the maxilla. At birth, what do you notice? You notice that the frontal process of the maxilla is well formed, but the body of the maxilla consists of just a little more than the alveolar process containing the tooth gems. You also have a small portion that you can distinguish from the zygomatic and palatal process. So at birth, maxilla is well formed. You notice that the body of the maxilla consists of alveolar process containing the tooth gems, and also you can notice the zygomatic and palatal processes. So the body of the maxilla is relatively small because the maxillary sinus has not developed. The maxillary sinus forms during the 16th week as a shallow groove on the nasal aspect of the developing maxilla. So at birth, you notice that the maxillary sinus is still a rudimentary structure about the size of a small pear. So you need to know that there are common features regarding the development of the jaws, that's the upper and the lower jaws, that's the maxilla and the mandible. Both the development of the maxilla and the mandible begin from a single center of membranous ossification related to a nerve. Both form a neural element related to the nerve, and then you have That's the developing bone. There's a like it forms a canal to enclose the nerve. Then the bone that develops also develops an alveolar element related to the developing teeth. That occurs for both maxilla and mandible. Then also common to both, you have secondary cartilages that's very important in the in growth of the developing bone.
Yes, so I'm still talking about the development of the mandible. So you have intramembranous ossification beginning the condensation, and it forms the first part of the bone of the mandible. You now have a trough of bone, that's a narrow channel of bone that extends to the midline, and here it comes in approximation with a similar one from the other side. So within the mandibular process, you have on the right you have the mandible developing, also on the left. So the two separate centers of ossification remain separated at the mandibular symphysis until shortly after birth. The ramus of the mandible develops by rapid spread of ossification, and this ossification, the ramus of mandible develops by a rapid spread of ossification, and the ossification spreads posteriorly into the mesenchyme of the first branchial arch, and as it does so, it turns away from the Meckel's cartilage. So you have this point of divergence, and at this point you have a landmark there. This point of divergence is marked by the lingula. So the ramus of the mandible is developing now by a rapid spread of ossification posteriorly into the mesenchyme of the first arch, and as it does so, it turns away from the Meckel's cartilage. And I say this point of divergence is marked by the lingula in the adult. So in the adult mandible, you see the lingula. So that lingula is actually the point at which the inferior alveolar nerve enters the body of the mandible. So what do you see by the 10th week of development? At about the 10th week of development, the rudimentary mandible is formed almost entirely by intramembranous ossification. The Meckel's cartilage is widely believed not to be directly implicated in ossification of the mandible. It's not believed to be involved, but now some believe that the Meckel's cartilage plays an active role, as it actually delimits the region where the mandibular bone formation should take place. So it gives the outline for the formation of the mandible. There is also the notion that osteogenic capacity of chondrocytes makes it possible for, in some regions, it's possible for the Meckel's cartilage to contribute to bone formation of the mandible. So due to the osteogenic capacity of chondrocytes that are present there. So that is the belief. So it's widely believed that the Meckel's cartilage is involved in formation of the mandible. So you have further growth of the mandible going on until birth, and the growth of the mandible is influenced strongly by the appearance of 3 secondary cartilages. These 3 secondary cartilages are also called growth cartilages because they are very important in growth of the mandible. And you also have, as further growth of the mandible occurs, you also have development of muscular attachments where muscles will be attached. So these 3 secondary cartilages are called, 1, the condylar cartilage, which is the most important. Then you have the coronoid cartilage and the symphyseal cartilage. These cartilages are referred to as secondary cartilages to actually distinguish them from the primary cartilage, which is the Meckel's cartilage. Well, you really need to watch the other video on this channel that has to do with development of the maxilla. So development of the jaws cannot be complete without development of the maxilla. So watch that video on the development of the maxilla. I really appreciate you for being part of my audience. Don't forget to share this video and like. Then you need to subscribe to this channel if you've not done so. Goodbye for now.